Welcome to the Technology Innovation Series of SH Vision. I am speaking from Fab Lab at Jyoti Engineering College. In the last session, we dealt with, or we made an interesting comparison between India, China and United States in terms of their supercomputing powers. And finally, I ended up by saying that even though India is still making its baby steps, a bright future is awaiting us. And CDAC is the pioneer in supercomputing education and development in India. Before going detail into the initiatives in India, I think we should understand the very origins of supercomputing. To begin that, I think we need to understand the beginnings of computing itself. There are some very interesting stories there. How computing was invented or first came into existence. It says that the father of computing is Alan Turing. Alan Turing was a British mathematician, and it was during the Second World War he got into action or got into prominence because the Germans, they were actually communicating between their U-boats, that is basically their submarines, using a very secret code, and that code was encrypted in a box, and that box is called Enigma. And it was an insurmountable task for the Britain and its allies to decode this code. And Alan Turing, with his colleagues, they set up a huge facility, a mathematical facility, to decrypt this particular machine, Enigma, and its code. And the history says that finally they were successful and they started to decrypt the messages, what their enemies were actually talking, and finally they won the war. But after the war, Alan Turing came back and he had this idea. Actually, machines could take up most of this work and do these kind of calculations on their own. And theoretically, he envisaged a machine. He never built a machine, but theoretically he laid the blueprints for a machine, and it is called Turing's machine, and that is considered as the first computing machine or computer. It happened in 1938. But interestingly, at the same time, on the other side of the spectrum, that is in the German side, in Germany, there was another researcher, another person. His name was Konrad Zuse, and he was also working on a machine, an electromechanical machine which could do the calculations. It was not a government funded effort, it was his personal effort. Finally, he devised a machine, and it happened in the same year, 1938. So we could say that the father or the origin of supercomputing is shared between, or the fathership is shared between Alan Turing and Konrad Zuse, but most of the time Konrad Zuse's name is not spelled very much. And that is the beginning of computing. But then later on, as you might have already known, the early computers were in huge facilities like big rooms, and they could do only very little. And they started to take the form of very compact machines, and finally they transformed themselves into the laptops and the desktops that we see today. But at some stage, there was another guy, and his name was Seymour Cray. Seymour Cray had this idea. Look, these machines are working at the moment, but I want really a powerful machine. I want to do these calculations quite fast, because some of the applications, they are time bound, they are real time, which means I need to get the answers immediately, otherwise there is no need, there is no sense of getting these kind of answers. So I want very powerful machines, and he went after these kind of powerful machines, and he came about with his first machine, that is Cray 1. Cray 1 is considered as the first supercomputer, and Seymour Cray is considered again as the father of supercomputing. And in the beginning, the supercomputers were monolithic structures, which means one big single piece, and they are connected to each other and they can do things fast. But as time progressed, commodity hardware, which means laptops and desktop, maybe servers, they became so cheap, and the researchers, they started to think in different lines. They were thinking, instead of having this monolithic structure, can we have a distributed structure or distributed architecture? So this change happened in the course of time, and they started to connect these small machines together. So they call it as blades or servers. They connected them using very powerful cables. These days they are called as InfiniBand cables, which means the messages can actually travel between these single pieces in a quite faster manner, so that the communication lag is very minimum. In technical terms, the latency can be reduced, and once that happens, these single separate pieces, they talk each other quite fast and do the work in a parallel fashion. So it is called parallel computing. And when we look into the top 500 list at the moment, most of the powerful machines belongs to this category. They are a distributed architecture, at the same time they use parallel programming. And this was the global scenario, but India had its own problems. India never had a supercomputer in the beginning, but India really wanted to get grab of these machines because of inquisitiveness. And the government made some advancements. They requested US, which had the Cray machines. The Cray machines, which was, by the way, the Seymour Cray, he created a new company, it is called Cray, and they started to produce supercomputers. And India wanted to get hold of this particular machine, but it was denied. In the 90s, it was denied to India because it was a kind of dual technology, which means it could also be used to create nuclear weapons. Since the US had put some sanctions on India because India had nuclear weapons at that time, they were reluctant to give these machines. Here came a problem for India. We wanted these machines, but the technology was denied. As in every other case, when there was a challenge, our scientists and researchers, they rose up to the occasion, and finally India started to build its own supercomputer. And the initiatives came from CDAC, and that story in the next session.